Submarines are precision machines, enormous and intimidating. Often, they don't even need to use their weapons. Just their presence alone is quite intimidating. But their greatest feat isn't in their size or their firepower. It's in the fact that no one knows where they are. And for that, they have an ability that no other vehicle possesses. The ability to submerge and emerge.
E emergiu.
According to Archimedes' principle, any body that is totally or partially immersed in a fluid is pushed upward by a force equal to the weight of the fluid displaced by that body. And this force is called buoyancy. Considering the submarine on the water, there are two main forces acting. First, there's a downward force, which is just the submarine's weight. The other is the buoyant force pushing it upward. So if the submarine generates a downward force of 200 tons, which is the weight of the submarine, and the buoyant force also generates 200 tons of force, but upward, the submarine will float. Both forces have equal magnitude and cancel each other out. In this case, it is said that the submarine has zero or neutral buoyancy. If the submarine generates a force of 200 tons downward and the buoyant force generates a force of 190 tons upward, the submarine will start to sink because the weight force generated will be greater than the buoyant force. In this case, the submarine is said to have negative buoyancy. And if the submarine generates a force of 200 tons downward and the buoyant force generates a force of 210 tons upward, the submarine will surface. In this case, the submarine has positive buoyancy, and it returns to the water's surface. So, we can see that for an object to submerge, emerge, or even float, the secret is to control its weight. For this, submarines have what are called ballast tanks, which are large reservoirs where seawater can be pumped in, increasing the weight and making the submarine submerge. Or release it, decreasing weight and causing the submarine to surface. These ballast tanks can have different shapes and be located in different positions, depending on the submarine model. But all of them have main ballast tanks, which are located more toward the center of the submarine, and trim tanks. They ensure fine adjustment and are located at the bow, center, and stern of the submarine. When on the surface, the submarine's ballast tanks are filled with air. In this case, the submarine has neutral buoyancy. When the submarine wants to submerge, the upper and lower doors of the main ballast tanks are opened. Then, a powerful system expels the air from inside the ballast tanks through the top, while seawater begins to enter through the bottom of the submarine. This way, the submarine becomes negatively buoyant, since for the same volume, water is many times heavier than air. This makes it denser and heavier, and the submarine begins to submerge. The ballast tanks at the bow, which is the front part of the submarine, are opened first. Next, the ones in the center are open, and finally the ones at the stern. The main ballast tanks are fully flooded, while the control tanks are partially flooded. When the desired depth is reached, the control ballast tanks are used to achieve neutral buoyancy and keep the submarine level. And also for making fine adjustments, since if the submarine is diesel-powered, it becomes lighter and lighter as the fuel is consumed by its engines. In addition to compensating for the imbalance of the submarine's center of gravity caused by the movement of crew and cargo. When it is time to surface, the submarine closes the upper openings of the ballast tanks and opens the lower ones. A powerful system then uses high-pressure compressed air to push water out from the submarine's tanks through the bottom. It then gains positive buoyancy and begins to surface as it becomes less dense and lighter. This makes it rise back to the surface. Submarines usually have two pairs of hydroplanes, with one pair located at the rear of the submarine. These are used together with the ballast tanks during the submersion and surfacing phases, as well as when the submarine is moving while fully submerged. The other pair, located closer to the front of the submarine, not only helps with descending and ascending movements, but also provides fine adjustments for leveling the submarine. Submarines also have a rudder, similar to the rudder on airplanes, which allows for left and right movements. The water temperature is also important and affects the submarine's ability to submerge and surface, since cold water is denser than warm water. So when the submarine sails through cold waters, it needs more water in the ballast tanks to be able to submerge. When the submarine is submerged, and especially when it's operating, since the submarine doesn't have windows and at great depths the sea is completely dark, if there's any obstacle like a stone, rock, iceberg, or even the seafloor, the submarine will collide with that obstacle. To avoid this, the crew uses nautical charts to get a good idea of the terrain they're navigating through. In addition, when it's submerged, satellite, radio, GPS, and radar signals don't reach it. And it was because of this that, in the past, American nuclear submarines loaded with nuclear missiles started to get lost. When they submerged, gyroscopic systems recorded every movement of the submarine. But over time, tiny errors would accumulate, and when they surfaced, they didn't know where they were. The Navy's solution to this problem was to launch GPS satellites.
Getting a picture of a maneuver.
So, when the submarine surfaced, they picked up the GPS signal and determined their location accurately. And that's how it's done nowadays. However, currently, submarines have sophisticated inertial systems and gyroscopes that can determine the exact location of the submarine more accurately when submerged. Occasionally, the submarine must refresh its internal air, and also the air for its engines if it's diesel-powered. Instead of the submarine surfacing fully, completely expelling the water from the ballast tanks and filling them with air, since it already has neutral buoyancy when submerged, it uses the hydroplanes at the rear and its propulsion to rise to what's called periscope depth, where the periscope, the snorkel, and other probes stay above the water, allowing engine gases to be expelled and fresh air to be taken in through the snorkel from the atmosphere. This is the most common way to bring the submarine to the surface. The propeller is also a key component in submarines, since submarines are machines designed to operate completely invisibly and undetectably. That's why submarines produce virtually no noise while moving, so they aren't easily detectable targets, especially for sound-guided torpedoes, and the especially lethal ones guided by the water disturbance caused by the spinning of the propeller. That's why a well-designed submarine propeller doesn't produce any bubbles while spinning, and it disturbs the water very little. The propeller is so important that many countries prohibit photos of their submarines' propellers. That's because knowing the shape of the propeller blades and their number can make it easier to obtain cavitation curve data through special algorithms. The reproduced acoustic signature can help identify the submarine when it's submerged. In other words, by observing submarine propellers, experts can determine with a certain degree of accuracy the noise they make when spinning and the type of disturbance they cause in the water when operating. And with that, they can develop torpedoes and systems that will easily detect the enemy submarine. That's why, when submarines are presented at public ceremonies, the propellers are always covered so they can't be photographed. What about ceremony photos where the submarine's propellers are uncovered? That's where a trick used by many countries comes in. When the propellers aren't covered, they're usually test propellers, which will be used during the testing phase for the submarine's certification, and later will be replaced by the final propellers that will go into operation with the submarine, and those won't be photographed. But in the first years of the submarine's operation, the propellers are still kept under lock and key, but after a few years, they're no longer so secret, and they start being shown more frequently in public.